Hi, in this series of recordings I'm going to go over chapters 5, 6, 7, and 8. These are kind of like flashcards, so I'm going to pause in between questions just to give you some time to think. So let's just begin. So we're given a quadratic equation in standard form, and I want you to state the x-coordinate of the vertex. The correct answer is negative b over 2a. Now remember, that just gives you the x-coordinate. There is a y-coordinate that goes along with it, and we'll talk about that here in a second. So let me give you some real examples. First, you have to locate the value of b. Negate it, and then put that over the double of the value of a. Answer is x equals negative 1. The next question. First, you have to locate the value of b. It doesn't seem to be present, so it's understood to be 0. Whenever you negate 0 and put it over anything, the answer is always going to be 0. So the x-coordinate of the vertex is x equals 0. Locate the value of b, negate it, put it over the double of a. Answer is x equals 1. Okay, and again, this just gives us the first partner in the ordered pair, the x value. So to find the y-coordinate now, you would take each of these x values that we've talked about and run them through the original equation to give you the y-coordinate. Okay, this is a completely different template, but it is still a quadratic equation. The coordinates of the vertex are hk. I'm going to ask you some other questions about this parabola as well. The pattern of the parabola, what I mean by that is, rather than charting out an xy chart, we can actually look at the value of a and use the 1a, 3a pattern. And that works with every parabola. You just have to multiply the value of a by these odd numbers. The axis of symmetry is always the x-coordinate, so that's h. And since it's a line, you do want to include x equals h. So let's take a look at an example. State the coordinates of the vertex. The correct answer is 3, 2. Some might be tempted to put negative 3, 2, but remember, the template is x minus h. H is the positive value. So what you can do is just kind of think the opposite of the sign given. The pattern, well, the value of a is 1. So you're going to go over 1, up 1, over 1, up 3, over 1, up 5, 7, until you have really no space left on your graph. And this is a pattern that you use starting with each preceding point. The axis of symmetry is the x-coordinate, so it's x equals 3. Here's another example. State the coordinates of the vertex. Describe the pattern. This time a is 2. So we're going to take 3 times 2, or excuse me, 1 times 2, 3 times 2, 5 times 2, which gives us the pattern 2, 6, 10. What that means is, starting at the vertex, you're going to go over 1 and up 2. From that point, you're going to go over 1 and up 6. From that point, you're going to go over 1 and up 10. And of course, a parabola is symmetrical, so they have reflection points across the axis of symmetry, which is at x equals 5. State the coordinates of the vertex. This one is a little tricky. We're missing the h value. So the coordinates are going to be 0, 8. The pattern, since A is 1, is over 1, up 1, over 1, up 3, over 1, up 5, so on and so forth. The axis of symmetry is the x coordinate, so it's x equals 0. State the coordinates of the vertex. Again, we have a missing piece. It's understood when it's not there to be 0. That's the k value. The negative on the outside of the parentheses, do not distribute it. You'd be violating order of operations. So the coordinates of the vertex are -7, 0. The pattern is going to be the same. This time A is -1, so the parabola is not going to be concave up, it's going to be concave down, but it's going to hold the same pattern. And the axis of symmetry is still the x coordinate, so it's x equals -7. Okay, let's move on to factoring. Usually in factoring you have these 4 options. If you can't factor, then you have to use other methods like the quadratic formula, but these examples will not entail that. Let's take a look at the first one. Inspect it. A common factor of 2 can be factored out, so GCF. Inspect it again. It will be a binomial, and because factors of 1 that add up to 2 are 1 and 1. Inspect it again, and after inspecting we can see that it is complete. Let's take a look at another one. Inspect it. Is there a GCF? Yes, there is. Each term has an x squared in it. What most people forget to do is they leave out that -1. Inspect it again to see if you have anything else like a special product. In this case, no. And if you did have a square right here, you would be able to continue, but since you don't, you're finished. Let's look at the next one. Inspect it. Is there a GCF? No. Are there factors of 12 that add up to 7? Yes. Inspect it again. You can see that you're done. Is there a GCF? No. So it's a box binomial. I'm just going to kind of review this process. If you multiply the A times C, that gives you 6. You look for factors of 6 that give you 5. They are 2 and 3. Throw those into the box right here. Put the first term in this box, and the last term in that box, and then do your GCFs. Okay, moving on. Is there a GCF? Yes. Factor out a 2. Inspect it again. Can we factor it any further? Yes. There's a special product. It's in the a plus b, a minus b template, which is x plus 3x minus 3 in this situation. -1. I. One. Never leave I squares in the sentence. Always change them to -1. And then simplify. Solve. The zero product property states if you have 2 factors whose product is 0, then one of the numbers has to be 0. Notice it's in factored form. Do not multiply the x through, that you're going in the wrong direction. Just set each piece equal to 0 and solve for x. In the first case, x is already solved. In the second case, you just have to subtract 2. It's in factored form. No point in foiling this. You're going in the wrong direction if you do. Set each piece equal to 0 and solve for each value of x. What must be done first to solve this equation? Since it is a second degree equation, we don't solve it by isolation. Once again, we solve it by various methods. But the first thing you need to do is set everything equal to 0. Try to keep your x squared positive. So pull your 5x and your 6 over to the left-hand side. And then from there, if you were asked to solve it, then you want to inspect it. Are there factors of 6 that add up to -5? The answer is yes. Set it equal to 0. And your two factors are 6 and -1. The number that completes the square, the formula is take half of b and square it. So the answer is 4. Same thing. Split it in half and square it. The answer is 9. The number in the box is always positive because whenever you square anything, you get a positive. 25. The role of the discriminant is to describe the roots. The general template for the discriminant is b squared minus 4ac. Now this is the part that is underneath the radical in the quadratic formula. The discriminant is, if the discriminant is negative, in other words, if the number underneath the radical is negative, then there are no real roots. They're imaginary. If the discriminant is positive, there are 2 real roots. It means there's going to be 2 strikes on the x-axis. If the discriminant is 0, there is 1 real root, and that root is the vertex. That concludes this set of flashcards. Hopefully, if you didn't get them all right, just go through them again. Good luck.